Second thing is to finish 3.12 notes. Bless. And then two times, bless you. And then we may have something special to do today. Depending on how good the questions are, I guess. First page. Any of those that you need help with, Mr. Tucker? I can. Oh, okay. Let me emphasize to you guys, the only way to get good at these is to practice. It is the only way. Most of these, are going to simplify fairly nicely. They kind of give you a hint, right? We're going to simplify it to secants. So we kind of have an idea. We'll probably end up with a cosine at some point, or a 1 over cosine. Probably. Maybe not. We might just end up with a secant, but we're probably going to end up with a 1 over cosine somewhere. So just kind of start. You can almost think backwards, if you will. If I know that I got to end up with secant, just what could I end up with, and those type of things, right? I see a 1 minus a secant squared, and I see a sine squared. And what makes these difficult, again, is there are several ways to do these questions. And I don't know which way right. I don't know which way is easier. You just got to get it practice. That is the only way to get good at these. It's the only way. I don't have anything else to say. 1 minus secant squared, I think, is one of those Pythagorean ones. And so picture yourself on test day. Anytime you see a 1 and you see a something squared, it's probably one of those Pythagorean ones. And so what I'll do is I'll go over here and think, okay, well, I know that sine squared plus cosine squared is equal to 1. Bless you. I don't have the other two memorized, or you might have them memorized by now already because you guys are freaking brilliant. I don't. So if I divide everything by sine squared, and again, I'm just doing this on the side here, then that's the 1, and cosine over sine is cotangent, and 1 over sine squared is cosecant. And I got secant. So I don't want that one. I want the one that I divide everything by cosine squared. So I'm going to go sine squared plus cosine squared is equal to 1. Again, I don't know that this is the way I'm going to go, but I'm going to look at it. Again. Cosine squared, sorry, and then cosine squared. Sine over cosine squared is tangent squared plus 1 is equal to secant squared. And I've gotten a mess up here now. So let me go over here again. So I know that this one is tangent squared plus 1 equals secant squared. That is one of those Pythagorean tricks. And again, if you know that already, you don't have to do this. But if you don't know that, we got to do this over here. This is kind of like your little side note, right? You got plenty of time on this test. Maybe not in class. Maybe not when you take this chapter test, like in here in this classroom. But when you go down to the gym and you take the AP test, there is so much time. You're going to be bored. You will be bored. They give you so much time to do these multiple choice questions. I don't want to say you'll be bored, but you're going to sit there going, oh my gosh, it's way plenty of time. So take your time and do this kind of stuff. Just make sure you got it right. You do not have to rush. Just keep thinking about that, okay? Well, I don't have tangent squared plus 1. I got 1 minus secant squared. And 1 minus secant squared is kind of how I have this, but I have to do some rearranging. In other words, the 1 has to stay here, but the secant squared has to come over here to become negative. And if that's the case, then the tangent squared has to go over there. And if the tangent squared goes over there, it's now negative. So I could have 1 minus secant squared is equal to negative tangent squared. This is not the only way to do this problem. And so 1 minus secant squared is negative tangent squared. And I drop all my x's and do all that stuff bad up there, and it's not really, I'm just doing it for me. They're not going to grade this stuff. This will probably be multiple choice anyway. But there is one that's not. There is something that you'll have to do like this that's a free response. And then now it's over sine squared. So all that work up here to get this to negative tangent squared. You won't have this nice little cheat sheet, if you will, that shows you all these things, right? I hesitate to give you guys those because you get so tuned into looking at it and then we take it away from you. So why would I give you something that's going to be a crutch with you that we know we're going to take away from you? Fair enough with what I'm saying. But I do it so you don't have to do a lot of this stuff either. It goes against my better judgment, truth be told. I don't like to give you the unit circle because you got to know it. I don't like to give you that little, you want to call it cheat sheet, formula sheet, whatever you want to call it, because you don't get it and I'm going to take it away from you. So I don't want you in the habit of looking at it, but I'm okay with you looking at it if you know how to get it, if you kind of follow what I'm saying. If you know how to get this from that, then you're okay to look at it. But okay, anyway, so now I'm here. Now I'm here, and I still don't have a stupid secant. I still don't have one. However, I know that tangent squared is the same thing as sine squared over cosine squared. So what I'm going to do now is change tangent squared into sine squared over cosine squared. And so this will now be negative, and I put the negative with one of them. You put it with sine or you put it with cosine. Don't put it with both, because if you put it with both, you now have a negative over a negative, and that's a positive. So I'm going to make this sine squared. And then I just kind of cheat, and I just put it on the bottom here, cosine squared. And then I got a sine squared. Whoops, darn it. Told you, I got a bad habit of dropping those x's. Don't do that. Don't do that. And now you got a sine squared over a sine squared. And if anytime you have anything over itself, they just cancel. And there's still a negative there, so it's just a -1 on top. And I still have the cosine squared. They want it in secant squared. And I told you guys, when you see that secant, you're probably going to end up with 1 over cosine at some point. And so we didn't end up with 1 over cosine. We ended up with 1 over cosine squared. But 1 over cosine squared is the same thing as 1 over cosine, or just secant squared. But it's negative. Negative secant squared x. That's how we get it. One way. There are a bunch of ways to get this problem. There are a bunch. Some students may not see that that's one of those Pythagorean, how do I say it? Pythagorean identities. And so you could, and I think I was helping somebody else with this. Oh, I can't do it here. Sorry. You could split that up into 2 separate fractions. Make it 1 over sine squared minus secant squared over sine squared. You could do that, and then get common denominators and doing. Y'all remember? Was it algebra 2 and your polynomials? Not polynomials, but you had this rational equation plus this rational equation. You had to get common denominators, and this one needed an x, and this one needed x plus 2, and that's kind of what you do end up doing. All this, all that stuff that you did, that helps you with this big time. Huge. Because there are times where you might want to split that up separately and just do it that way. Let me kind of show you what I mean. I don't know what this is. What's going on here? I love this board. Not responding. What's the, you computer guys and girls, what's the yearly length of what's the length of a computer? How long before they decide they're old? 9 to 10? I'm in that window, but okay. I think this one's 8. Anyway, what was it? 1? Oh, I have to wait again, I think. Yep, here it comes. Oh, there it is. What was on bottom? Secant squared? Sine squared. Those were sine squared, wasn't it? Secant squared. You could do this. split it up into two separate fractions. You could. 1 over sine squared is now cosecant squared. It's going to take you a little bit longer to get there. You're going to have to use a Pythagorean identity at some point. But you could do this. This is fine. This is now cosecant squared. And this is, yuck. 1 over cosine squared. And then sine squared. And this is going to need a cosine. Holy cow, you start seeing that. It'd probably be a better way to do it. It's not wrong. There's just probably a better way to do it. Because you for sure haven't started off with something and started making it look simpler. It's starting to look worse. Anyway, the only way to get good at these is just to start getting comfortable. Just get comfortable with them. You'll ask any math teacher up here, well, I shouldn't say any of them, but most of them that can remember doing this stuff, they all say they love it because we're nerds. And you start off with something that looks a little complicated and you end up with something really, really nice and simple. And when I was in school, they had these things equal to something. That was what, secant squared? That's the way they showed them. And so you knew what you had to get to. And you no way you would start with that over there and end up with this over here. You would start with this and end up with that. So you knew the answer. You just had to get there. You still kind of know the answer. You know you're going to end up with secants. You just got to get there. So I think we just like these things. Because you know what the answer is. You just got to get there. That was a big, long topic about something that, yeah. Good? Get rid of that. Go back to this. Another one. Another one. Yes, ma'am. On this page right here, yes? I got to take it off this, go down to 5. Yuck! Rewrite j of x as a function involving powers of sine and no other trigonomic function. So we're going to end up with sine somehow. And currently, I got a secant, I got a cotangent, and I got a tangent. And I think the best thing to do is just turn things into sines and cosines just to get started. I don't see a 1 plus or minus or anything like that, so I'm probably not going to use one of those Pythagorean theorems. Pythagorean identities. So I'm going to jump right into it, and I'm going to make secant 1 over cosine. Y'all remember, right, the C and the S flip-flop it. So when you flip-flop the S and the C, that's where you get cosine. That's how I always knew that those go together. Cotangent is cosine. Oh, this is nice. Oh, that's nice right there. Those are kind of like, oh, what do you call that in science when you're trying to unit conversions? What do you call that? What is it? No. You start off with like minutes per hour and you're trying to go to millimeters per second or something. Is it metric conversion? It's not metric, but it's some type of conversion. Anyway, who cares? And then tangent squared is sine squared over cosine squared. Just, you got to be nice and neat about these things, and you can't forget a square or something like that. And so I have a cosine on the bottom, I got a cosine on top, and I got another 2 more cosines on bottom. So really I got 3 cosines on bottom, but I'm going to take that one away. I'll just take that one away. And then one of these sines will get one of those bad boys. Because you got sine squared and you got a sine on the bottom. Everything's multiplied, so they're all factors. Luckily, I don't see any pluses or minuses. If you see pluses and minuses, that's where we try to do magic math. Don't do magic math. And so right now, I have a sine on top and I got a cosine squared on bottom, and it wants me as powers of sine and no other. So I got a sine on top and I got a cosine squared on bottom, and I got to use it in terms of sine. And you got that one that says sine squared plus cosine squared equals 1. And if that's the case and I have a cosine squared and I want things in terms of sine, I got to put that sine over there. And so now cosine squared is 1 minus sine squared. And so I'm going to end up with a sine on top and a 1 minus a sine squared on bottom. And it's in terms of sine, I'm stopping. Can you do other things to that? Yep. But they just want it in terms of sine, I'm stopping. I'm stopping. When we got these equations, we would have it equal to something. And so we knew where to stop. You kind of have an idea where to stop because you stop when you tell you where to stop. What if I kept on going? Okay, it better be right, and you better have nothing but sines. But once I get it to sines, I'm stopping. Don't go any further. You've answered their question. Hopefully this move right here was fairly easy for you. It's seeing that. And if you end up with one of those squares, you're probably going to use a Pythagorean identity at some point. More than likely. And you just got to know those Pythagorean identities. And really, you only got to know the one. Sine squared plus cosine squared is equal to 1. If you know that one, you can get those other, I don't know how many they got down there for you. 9. 3 different ways of writing each one of them. Hopefully you can get those from it. Yes, no. Good? Good, Em? Watching me do these is not going, I mean, if you tried this and you got stuck and then you see me do it, hopefully that helps you. But if you just watch me do it, I'm pretty good at these things, right? But I've been doing them for longer than y'all been alive times 2. I used to not be able to say that. Every year I get a year older and you guys stay the same age. You don't, but my students do. Yes, sir.
You do number 6 on the other side?
Yep.
Would you do number 6 on the other side?
I will. I just don't remember where it's at. Does it say B at the top of that page? Okay. When I gave you guys this, I hoped I gave you all the formulas that you needed. I just threw it out there. So there may be something on there that you couldn't do yet. Because there's 2 of those I didn't go over yet. The double and the half. Was it the double and the halves? I know it's a double. It doesn't matter. We'll do it. So it was this one. And it's not this one. It's the second page, which is, oh, this is it. That number 6 over there. Woo! I'd just love to cancel those cosecants out really easily. But you do that and I won't have to chop your head off because you're no good to society because you don't understand anything about mathematics. You can't just cancel those out because they're not factors. However, I got a cosecant squared minus 1 and I'm probably going to use one of those trig identities. Probably going to use one of those trig identities. You can, this one might be better if you don't use a trig identity and split it up into 2 fractions. So let me side note this, just to make sure you guys remember your common mathematical stuff. You're not used to seeing. Turn the page. Thank you. Now it's going to turn again. I've got to wait. Wait for that to go to a 3. If I start writing on 2, it's going to, there it is. You guys are used to seeing them like this, combining them, getting a common denominator. You're not, the way we got this is you started off with that. If I do this, I got common denominators already. I can do x plus y and just put it all over z. Those are the equivalent. This is not equivalent. I can't make this x over y plus x over z. I can't do that. Because if I get common denominators over here, well, this one needs a z and that one needs a y, and then I got xz and I got a y, not even close. So you can't do that, but you can do this one. Just, I mean, it just makes sense, but I know it's been a long time since you kind of really, we're not used to going this way. We're used to going this way. And so when we change it up by going a different way, you're kind of undoing something that you're used to doing. Sometimes that helps. And this time, you see that cosecant squared minus 1, especially in parentheses, they want to kind of keep that together, and they're trying to trick you. But if you got a cosecant squared minus 1, you got a cosecant, I think I'd split that up into two separate fractions. And that would make it cosecant squared over theta cosecant squared theta minus 1 over cosecant squared theta. And then cosecant squared over cosecant squared is 1. And 1 over cosecant squared is sine squared. And 1 minus sine squared, let's see, sine squared plus cosine squared is 1. Sine squared plus cosine squared is 1. I got 1 minus sine squared, that's simply cosine squared. And my bet is, what's one of those choices up there? Yes, sir. Yep. Y'all okay with that? That is not the only way to do that problem. You could have changed 1 or cosecant squared minus 1 in one of those Pythagoreans. And my bet is some stuff started canceling out. But at the end of it, you're going to end up with a cosine squared. Were all those cosines and sines? No, there's a secant up there, and there's a 2. Which one you said, number 5? Probably make secant 1 over cosine. Probably. I don't know if I'm going to or not, but I'll start there. I just try to make things into sines and cosines. It's just a little. Normally that gets me where I'm going. Tangent sine over cosine. Ooh, I already got a sine up there. Is that going to mess y'all up if I make that sine squared? I already got a sine up there, and I got tangent sine over cosine, so I got 2 sines on top. Uh-oh, that's not squared. And I got common denominators already. So when I have common denominators, I'll combine them. So 1 minus sine squared. 1 minus sine squared over cosine squared. We just did that. 1 minus sine squared is cosine squared. So I got cosine squared over cosine squared. One. Well, I don't know if there's any other way to do that. If you were really unsure about yourself, make theta pi over 2. I don't think I'd make it pi over 2. I'd probably make it like pi over 4. Make theta pi over 4 and stick in your calculator. Do sine of, what, did I mess up somewhere?
It's not cosine squared. Yeah, it's not cosine squared.
Oh, it's cosine. Oh, cuss. Thanks. I knew that was going to mess me up by not erasing that. I saw quite a few of y'all look at that weird. Thank you. All right. So 1 minus sine squared is cosine squared over cosine. Let's go ahead and show that. There, cosine theta. Sorry. Thank you guys for catching that. What do you like about it? What you don't like about it? Makes dollars? I like to make dollars instead of cents. Shut up. Y'all Y'all would laugh at this. Y'all may not laugh at this. I laughed really, really hard last week, Thursday. No, yeah, maybe Thursday, Friday. I don't know. One of the other teachers was going over their inequalities, right? And she was having a problem with her board, so I went in there and fixed them. I'm walking around looking at all the kids' work, and I mean, one of those questions took you guys. I don't know how you got it done in that one little area. Like you probably needed your own paper to get it done. And I just go, man, that's a lot of work. That's cool. And I'm looking at somebody else's, man, that's awesome. I said, y'all wait just a little bit. She's going to show you the easy way how to do that. There's not one. But they all look like, and she looked at me and got very mad. There's not one. Oh, yeah, there is. You need to show them how the easy way how to do that. So you can do that problem in 2 steps. What? She had to spend the whole class period trying to fix it. There's not an easy way. I love doing that stuff. See, it's not just kids I mess with, it's adults too. What other one do I need to show you guys how to do, or where you got stuck at? Talk to me. Number 7 on this page. This one down here, yucky. Holy cow. Yuck. Cosecant 1 over sine. So if this is 1 over sine, and I already got a sine down here, this is the same thing as 1 over sine squared. How much work you need to show on this, basically, I need to be able to follow it. And I'm pretty good. So I don't think you don't have to show this as 1 over sine and then show it as this. I mean, if y'all kind of follow what I'm saying. You have to show your work on this stuff because I have to be able to follow it, but how much you have to show, like that one previously, I better not just see cosine at the end, right? If I just see cosine at the end, you either guessed or got it from your buddy or did your work on another piece of paper. And there's no reason to do that. Cotangent. Ugh. Cotangent is cosine over sine. And tangent is sine over cosine. Uh-oh. Sorry. See, I messed up by not showing enough. Uh-oh. I messed up. Tangent is sine over cosine, but sine over cosine's in the denominator. So it's sine over cosine. When I flip it and multiply it, it's now cosine over sine. Or tangent is 1 over cotangent. And if you do 1 over cotangent and you flip it, you get cotangent squared on top. Maybe that was the best way to do that. I don't know. Probably was. Yeah, looks like it was. So when I flip tangent, it now becomes cosine over sine, which is No, I'm good. I could leave it like this because I have common denominator already. I got sine squared and sine squared. And so if you have common denominator, you can put the fractions together. And so you have 1 minus cosine squared over sine squared. It's not 2 sine squared, or it's not 0. The denominator stay the same. And 1 minus cosine squared is sine squared. And sine squared over sine squared is 1. I knew I'd get one of these to 1. Did I mess that one up? And that one, I don't know if there's 29 different ways to do it, but there's a bunch of different ways to do that problem. A bunch. And I don't know which way is easier or harder. Whatever you see is the easiest way to do it. I just have a bad habit or a good habit, I don't know, of changing everything to sines and cosines right when I see questions. And if there are already sines and cosines, then I'm stuck. Probably got to get common denominators or something, I don't know. Yes, no, maybe? Good questions. The only way to get good at these is to practice. That's the only way. And if you want more, I got 3 different pre-cal books that I can find probably 60 in each question, in each book. And they start off easy and they get brutal. AP pre-cal doesn't get brutal. These are not, I mean, these you can get done about 3 steps. There are some that would take 15 steps to get there. Yay, good. What else? Could y'all do all of those? Like you didn't need those other, there's 2 others we got to go over. We'll go over them today. I didn't want to give you all of them in one day. There's 2 ways of looking at it. I don't know which one's better or worse, but yeah, the sum and differences and then the double angle. Okay, we're good? Ready to finish this up? Let's finish up our notes. We'll go to the bathroom. Don't do it there. Kind of bad. You got to walk in front of everybody, isn't it? Is what it is. Okay. 2, 4, 6, 8. Those 8 you got to know. I'll be honest with you. I don't think I hardly ever use that one or that one. I don't use those very often at all. Tangent is 1 over cotangent, and cotangent is 1 over tangent. I don't use, because I just turn everything into sines and cosines. Sometimes it's advantageous to use that. 2, 4, 6, 8. So those 8 you got to know, right? And then we talked about the Pythagoreans. Here's the proof of the Pythagoreans. It's a pretty easy proof, but you don't care about proofs because I don't care about proofs. And then the 3 trigonomic Pythagorean identities in the paper that I gave you converted these into like 3. If you know that one, you should be able to come up with the other 8, 9, whatever they are. Okay? So this is the one that I know, and I may have to do some rearranging. But anytime you see 1s and you see some squares, you're probably going to use a Pythagorean one. Anytime you see 1s and some squares. And sometimes you may have to see some squares and turn it, bless you, to the 1s, but that doesn't happen very often. What I mean by that is you may see a cosine. We had to do that on one of them, I guess. You saw a cosine squared and they wanted everything in terms of sine. So cosine squared is 1 minus sine squared. So sometimes you have to do that, but most time you're starting off with a 1 and one of those squares, and you got to turn it into the single square. Sometimes it's negative. Let's see if we can find another identity by using the unit circle. Boom, 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 boom. This is good to know for future. The radius is always 1. The radius is 1. So the radius is 1. And if this is x, right, that's the x value, then you can find y, or find the third side by using Pythagorean theorem. A squared plus b squared is equal to c squared. So rather than make this y, they make it 1 minus x squared square rooted. Because if you do x squared plus, let's do b squared. A squared plus b squared is equal to c squared. Okay? And I move the x squared over here, and I take the square root of both sides, then that would be that third side. Again, just notice that. This is part of the proof. You don't need to know that, but it will help you in something. I just remember that coming up somewhere. I think it's in 13 or 14 or how many do we have? Y'all know? Have y'all looked that far ahead? Is it 14? 15? One of them's bad. I think it's 13. 13 is bad. I will not come into 13 without doing it first. Everything I've done this year, I don't do it till I come into this class period. Because I think it's okay for you guys to see me struggle too. I think it's okay to see that. Anyway, you don't care. So they're showing you all this stuff, all this stuff, all this stuff, all this stuff. Oh, this is the inverse one. We won't use these three. Is that on your sheet at all? Y'all have your sheet in front of you? Who has that sheet in front of them? Is that on? Is the inverse in front of you? You don't. I don't know why you don't need those. That was example 3. All right, here we are. Sum and difference formulas. Sum and difference formulas. Yep. Sure. Okay, so there are 4 of these. 4 of these. And I don't know how you want to memorize it. If you want to memorize a process, if you want to use, as we get closer to the AP exam, you're going to hear me talk about brain dump. Brain dump. You're going to get a blank piece of paper that you can do all of your work on. It's going to be blank. And my suggestion as we get closer is to brain dump everything you need to know, any formulas, anything on that piece of paper. And you have that piece of paper for the whole exam. Good. So if you need the unit circled, brain dump it on that, and that way you don't have to do it 4 or 5 times. Brain dump the identities if you need it. These are maybe some that you might want to brain dump. I don't know. Some of you may not want to. You may not want to do it until you need it. If you kind of, right? Because there may be one question on this. So I don't know if you want to brain dump 4 different things for something you may only need 1 of them. But again, here we go. So they're going to call these the sum and the identity, or sum and difference identities. Okay? And it's really bad because it's not what you guys would think would happen. Okay? So we'll start off with sine. I just have a bad habit of this. Oh, sorry. I don't want to use y's. Let's do this. I'm sorry. Okay. Sum difference identities. And I'm going to look at the sum of sine. Okay? The sum of sine. You would think, because you guys have seen algebra and you've seen distributive property for your whole life, that you would just distribute that sine to both of them. But that's not what you're doing, because sine by itself is absolutely nothing. Like, what? Just like this. Of what? Right? Without putting a number right here, that means nothing. It's like this. I mean, it means nothing to me without a number. So this is not sine times that, because there's no such thing as sine by itself. It's the sine of that angle, whatever that is. And so what they're going to do, the reason why they do that is because you know what A is and you know what B is, and if you combine it, you don't know what A and B is. Oh, there's my other pencil. Okay, so it comes up to this. Sine, this is how I remembered it. Sine is social. You go to a party or get together and you're social. When you're social, you like to talk to everybody. You like to talk to everybody. And sine likes to talk to cosine because he's social. So sine, social, goes with cosine. And sine also starts with an S. And S, it means same. So if that's plus, that's plus. If it's minus, it's minus. And now because sine's social, the B is going to talk to the A. And so I don't care how you want to write this. Some will write it as sine B cosine A, and some of them will write it as cosine A sine B, but multiplication doesn't matter. Multiplication doesn't matter. If you do x times y or y times x, it's the same thing. So sine A cosine B, and then the other two, sine B cosine A. Sine's social, so they go with both. He like social, likes to be with other people. If that's a minus sign, let me turn that to blue. It does the same thing, exact same thing. We'll do sine A cosine B, but minus. And then we'll do same thing. Sine B cosine A. Or cosine A sine B. If this one's sine A, that one has to be sine B. And if this one's cosine B, that one has to be cosine A. Don't put sine A cosine B and then sine A cosine B, because if you subtract that, that's 0. And it's not 0. So it has to be, you have to use each one of them. Woo! Sharpie! I'm not up here for my health. You need to apologize to everybody because they all peed in their britches. Okay, sorry. I used to get the stick out, but I hit somebody one time and got in trouble. They said I can yell. Y'all okay with that? Okay? Cosine, on the other hand, cosine's cliquey. He likes to stay together. He doesn't like to be social. So cosine's cliquey. So cosine stays together. And because cosine likes to stay together, that's a bad thing. Being social is a good thing. Being a bad thing, if it's a bad thing, it's the opposite. And then we're going to do sine A, sine B. And if it's a minus, it does the same thing. We'll do cosine A. Sorry, dang dyslexia. Cosine B plus sine A sine B. And I don't know how you got to memorize that. I don't know. Cosines go together, sines. I like my social and cliquey. Sine, social, cosine, cliquey. I've seen this before. And this may help too. I don't know. You got sine A plus B, and you got sine. This might help you on brain dump. A minus B. And then you got cosine A plus B and cosine A minus B. These are the four you got to know, right? I don't know which one. You don't have to know all four of them for the test because you don't have to know one of them, but we don't know which one. So one way I've seen this is to write down like sine A, cosine A, cosine A. Okay, so write sine A, cosine A, cosine A. And then just write down cosine B. So write down the trigonomic function, and then the second one's cosine B, all the way down. And of course, sine is the same. So plus, minus, and cosine's bad. That's the opposite. Negative, positive. That was always the hardest thing for me to try to remember is which one a negative and positive went with. I just did sine same, so cosine is not. I don't know. And then we're going to write down the opposite of this one. So we write down exactly what it says, then we write down the opposite. So we'll write down cosine A, sine A, sine A, and then we just write down sine B for every other one. Might help you on brain dump, I don't know. That's almost easier way to write it, but I don't know how you guys got to memorize those four. However you got to do it. However you got to do it. There's a story. Never heard it before. I didn't get all this cool stuff like you guys did. Sent. Oh, good gracious. When did I send that? I'll find it some other time. I don't have time for this now. Should have pulled it up. Yep, I don't see it. Oh well. Where am I at? Nope. Here. Okay, y'all good with that? They call them the sum and differences. Sum and differences. Where am I at? Let's go back to this thing. So that's why they show it sine, and they use alpha and beta. That's probably a little bit better than A and B, but who cares? Alpha and beta, and then they put plus on top and minus on bottom. And so it becomes to sine, cosine, it's social, and the signs stay the same, so it's plus minus. And then cosine's clicky. So it's cosine A, cosine B, sine A, and then you got to flip the signs. So it's positive on top, it's negative on top, and it's negative on bottom, it's positive on bottom. So that's all four of them written like that. And then the double angle. The double angle. This can be shown by this. You can actually get this from this. In other words, this is alpha plus alpha, because alpha plus alpha is 2 alpha. So alpha plus alpha is 2 alpha, and so then I would have sine A cosine A, and then cosine A sine A. And if you have a cosine A and a sine A and another cosine A and a sine A, then you add them together, you have 2 cosine A sine A's. So that's the double angle for sine. This is one you guys end up going to calculus. You got to know that one. That one is used more than probably any other identity besides the tangent and cotangent. The Pythagorean is used second. You guys are lucky. We have to know the half angles, and I think there's 20 something identities. We have to know them all. These are the only ones you got to know. And then cosine double angle ends up being cosine squared minus sine squared. Cosine squared minus sine squared. Which is weird because we're used to saying sine squared plus cosine squared is 1. And they want cosine squared minus sine squared, which is different than sine squared minus cosine squared. Now, you guys know that sine squared plus cosine squared is 1, and so that's how they got this one. And that's how they got this one, by using the cosine squared plus sine squared is equal to 1. I don't ever remember those last two. I just remember the cosine squared minus sine squared, because you can get the other two from the cosine squared plus sine squared is equal to 1. Okay, here we go. 29 cats in here, 29 different ways to do this problem. Right now, if I asked you what sine of pi over 28 was, you'd have to go to your calculator because you don't know how to do that. Nobody knows sine of pi over 28. However, I can make that a trigonomic identity somehow, some way. So I'm going to get 28 by doing over 3, over 6, over 4, over 2. I've got to split this up into one of those that I know. A sixth, a fourth, a third, a half. Y'all follow what I'm saying? You know the sixth, you know the fourth, you know the thirds. I've got to get the 28ths somehow. Somehow. You got to split that up. And you can do it with sums, or you can do it with differences. However you got to do to get 1 over 28. 1 over 28. 6 and 4 will give me 20. That doesn't help me any. I got to get 28. So split 28. Let's see, how am I going to get 28? 2, 12, 6. Y'all follow what you're seeing what I'm doing, right? I'm just trying to get two fractions that either add or subtract to 1 over 28. 1 over 28. 7 and 4 will give me 28, but I don't know the sevenths. I do know the fourths. Y'all follow what I'm saying, right? The 7 and 4. So if this was a 7 and this was a 4, I need a common denominator 28. But I don't know the sevenths. I know the fourths. So I can't use 7 and 4. Hit me. I don't know if I want to split it 3 times. I don't think I want to split it 3 times. Because my sum and differences only have 2. Yeah? Hit me. Oh, you want to use a double? Oh, you want to use a double. Then we'll use oh. Somehow or another, you got to use a double. You don't get to use the halves because we don't give you the halves. You got to use a double, or you got to use the sum and difference to get 28. And I'm trying to find a sum and a difference to get me 28, and that was 7 and 4. 2 and 14, that doesn't help. There's nothing I can think fraction-wise that I can add and subtract to get 28s. So I probably can't do that. Y'all good? This is the process that you would have to go through just like that. So I don't think the sum and difference is going to be able to do it. So I'm probably going to have to use the double. And because it's sine, hopefully I got a double somehow. So if I take 1 over 28 and so how'd you end up doing it?
So you have sine of 2 theta, right?
Yeah.
2 sine of theta and cosine of theta. Well, we have the sine of theta and cosine of theta, which is 14. If that is if sine of 2 of theta, so the theta is to be pi over 14, so it's sine of 2.
Oh, I see what you're doing. I'm sorry. I'm trying to make this is not a, there's freaking questions over there. I was really trying to figure out how the heck I was going to get this answer. Sorry. There's a stupid question over there. That teaches me to go into this blind Neil. 2 sine theta cosine theta. Y'all see that? I'm trying to see which one of these is the answer to that. Idiot. I'm an idiot. I'm an idiot. Put y'all back in stupid groups, except I got to give y'all a quiz. So that's like 2 sine alpha, cosine alpha. And if I distribute that, this is the formula saying basically it's 2 alpha. So this ends up being sine of 2 times pi over 14. Basically, I'm rewriting it. Hit me. In the parentheses. Well, either way. Yes. Either way, it doesn't matter. But good. I mean, that's just rewriting the formula. And 2 times 14, pi over 14 ends up being 2 pi over 14, and 2 pi over 14 is pi over 7. Simplifying it. So I end up with sine pi over 7. Right there. Hit me.
Are you doing the opposite?
No. I'm just simplifying it.
It's not like a V thing where you're.
No. I'm not graphing it. I'm not trying to figure out what the period is. Thank goodness. That's going to make a stupid line. There it is. Yes? They gave it to me like this. 2 sine pi over what? 14? Pi over 14. So if this is pi over 14 and this is pi over 14, then this has to be pi over 14. And still multiply that together, and 2 times pi over 14 is just pi over 7. Just, yeah. I'm not figuring out what the period is. I'm not doing anything else. I'm not doing opposite what it thinks. It just, what does it simplify to? Everybody okay? Yes? No? What does it simplify to? I don't know. I can't simplify that to anything. I can't get that one. That's why I was having a tough time. K is given by 4. Oh my goodness. Cosine 2x. Which of the following is equivalent? So I've got 4 cosine 2x. 4 cosine 2x. Is that going to go? I just love the speed of my computer nowadays. It's driving me nuts. I'll go back to chalkboard. Heck with it. My first year teaching, I had chalkboard. My second year, they replaced all of our chalkboards with whiteboards. What is this thing? 4 starts off with? Cosine? 2x? Is that it? I think I'm going to leave that 4 by itself right now. It's 4 times cosine 2x. And cosine 2x is the same thing as cosine squared x minus sine squared x. And I could distribute that 4. But right now, I got to look at their answers to see what I got to try to get. Because my bet is that's not any of my choices. Good enough? So let me go back and let's see what their answers are. I got an 8, I got a 4, and I got an 8, and I got a, Oh, that's a plus. That's close. That was close. But I'm not going to get that one. So now I got to look at, I don't think I'm getting this one either. This one they're trying to make me do sine. I can't get that one because I got a stupid plus and a minus. So we're down to 2. And now I've got to use a stupid sine squared plus cosine squared thing. And I don't know which one I got to use. I may have to use one of them, and maybe that's one of the answers. And if that's not, then I got to use the other one. So I know over here that sine squared plus cosine squared is equal to 1. And so I got to use one of these. And so I'm going to do 1 minus sine squared. So cosine squared is 1 minus sine squared. And if cosine squared is 1 minus sine squared, I still got this 4, and I got a 1 minus the sine squared. And I got a minus the sine squared. And if I have a negative sine squared and a negative sine squared, that's a negative 2 sine squared. So 1 minus 2 sine squared x times 4, distribute the 4. So I end up with 4 minus 8 sine squared x. Is that one of my choices? That's not, so it's got to be the other one. I'll prove to you that that one shows up. Okay? So that other one says, then sine squared is equal to 1 minus cosine squared. Sine squared is 1 minus cosine squared. I'm starting to get all over the place, but I want you guys to, this one's harder to do than the other one because of the stupid minus sign. So this becomes a negative 1, and this becomes a negative cosine squared, and a negative cosine squared is a positive cosine squared, and that positive cosine squared with this positive cosine squared gives me the 2 cosine squared. Let me walk through all that again. So me changing this to 1 minus sine squared did not get me the answer. Now there's only one other choice, so that should be the answer, but let's prove it. So I'm going to change this one to 1 minus cosine squared. So when I change this one to 1 minus cosine squared, there's a stupid minus sign in front of that. So this minus sign goes with that 1 and makes it a minus, and this minus sign with that makes it the plus. And this plus cosine squared and this cosine squared gives me the 2 cosine squared. Y'all see why I don't really want you looking at this stupid formula sheet thing? Because you don't have that for the test. So you got to kind of do all this stuff with your brain. So if you just constantly are looking at that and back and forth, you're going to be in trouble on test day. Just keep that in mind, okay? So this cosine squared with this cosine squared, this cosine squared with this cosine squared gives me that 2 cosine squared. So that's that 2 cosine squared minus the 1. And then I got that 4. And so I can distribute the 4 and give me the 8 cosine squared minus 4. And that's the one of them. Was it B or A or C or? Y'all good? I'm really regretting giving y'all that piece of paper because you're going to use it as a crutch. Don't. Use it to help you, but how about a quiz sometime soon about writing down all the identities? Give you a piece of paper and say, give me the identities.
Even the inverse ones?
No, not the inverse ones. The reciprocals, Pythagoreans, sum and differences, and the doubles. Yep.
Would it be like sine squared plus cosine squared equals 1, and then we have sine squared equals
I don't know. I don't know. It's not on your next one. It's not on the one today.
It's on the one today.
Yeah. Solving inequalities, equations. Not today. It's not the double or the halves. It ain't easy. Solving's hard. Told y'all that was hard. Where am I at? Here. Okay. Which one did we end up with? See? Sometimes it's easier to figure out which ones are not the answer than which one it is the answer. Sometimes. In your multiple choices, 2 of them typically never make sense. You just got to choose between the other 2. Which of the following is equivalent to cosine pi over 8, cosine pi over 16? Yuck. Boy, I wish that was the same angle, but it's not. But you got a cosine and a cosine, and a sine and a sine. What the heck? A minus and a minus? What? Oh, those are fractions. Cosine is clicky. Sine is social. So I bet that's a cosine double angle. And you almost have to just kind of recognize that that's the cosine double angle because you got some angle. Dadgummit. You got some angle and some angle, and they're not the same angle. If they were the same angles, you could combine that together and make it cosine squared. But you can't. So this is a cosine of some angle and a cosine of some angle, and that's a sine of some angle, and that's a sine of some angle. And there's a minus sign between it. And when there's a minus sign between it, that's going to change it to the positive because clicky's bad. We like to be social. Clicky's bad. So this is the same thing as cosine of A pi over 8. The minus is going to turn to a plus pi over 16. That's the answer. I don't have any of them that look like that. So my guess is I got to do pi over 8 plus pi over 16. And pi over 8 and pi over 16, this is 2 over 16. And 2 over 16 plus 1 over 16 is 3 over 16. I got one of those. I got one of those. It's going to take some work on you guys. You just got to, once you do it and you do it and you do it and you see it and you see it and you see it, it becomes a whole lot easier. Right now, it's brand new to you. Like, how in the heck, what am I supposed to do with that? You just got to recognize that that's the sum and difference one. You got to recognize that the other one is a double angle. That one is a double angle. It's not a sum or difference. So you just have to recognize, is it a sum or difference? Is it a double or is it an identity? Is there another one of these? What else we got going on here? Oh my gosh almighty. What the heck do I have going on here? Is this one on yours, right? That's good? Okay, just checking. The figure shows a circle centered at the origin with an angle to measure theta in standard position. Luckily, it's in quadrant 1. Got a terminal insects with the coordinates of P are 5, 12. Which of the following, is the sine double angle? Oh my gosh, this is not a unit circle. This is different. So this is 5, 12, 13. They actually tell you it's 13 out here. But you should know the 5, 12, 13s and the 3, 4, 5 triangles. Sine 2 theta. Sine 2 theta. I don't know what theta is. Sine is opposite over adjacent. But sine of 2 theta is 2 sine theta cosine theta. Theta is in quadrant 1, and sine of theta is opposite over hypotenuse. So sine of theta is opposite over the hypotenuse. Cosine of theta is the adjacent over the hypotenuse. And 2 times 5 is 60, times 2 is 120 over 13. It doesn't simplify. Sorry for you guys in the back, it's way down low. Yes?
120 over 169.
Oh, it is. You got to. Well, I'm not adding. Dadgummit. Sorry. Chop your head off. Move right there. I did 2 times that times that. I just didn't do that times that. Stupid. Sorry. Thank you. Chop your head off right there. That's mine. Dang it. That's mine.
Why did you chop that middle?
Guys, I didn't multiply the 13 because I'm stupid.
Well, you're stupid. I'm gonna tell me about it.
I just got smarter.
Always got your-
Somebody told me. I was confident in my answer, was just confidently wrong. When you add, you leave the denominator, but when you multiply, you got to multiply. Multiply across the top, multiply across the bottom. General math. Oh, yucky. -5 root 11, and the hypotenuse is 6. They're giving me all that. So this is -5. That's root 11. And this is 6. The hypotenuse or the radius is always positive. Always positive. Can't be negative. Yet. Huh. Figure shows 2 circles centered at the origin with an angle. So I got another circle over here. This one's alpha and this one's beta. And that one's 2 root 5, 3. 2 root 5, 3. 2 root 5, 3. The figure shows 2 circles at the origin. The coordinates are that and that. Beautiful. Find cosine 2 alpha, or 2 alpha. And cosine of 2 alpha is cosine squared alpha minus sine squared alpha. You got to just know that. And cosine of alpha, is adjacent over hypotenuse. -5/6. -5/6, but I'm squaring it. I'm just squaring it. I know this is way at the bottom for you guys in the back. I'll move it up in just a second. And then I got to do sine squared. And sine squared is opposite over hypotenuse. And so it is root 11. Root 11 over 6, and it's squared. And so I'll have +5 over 36. Negative, the negative sign's not squared, guys. Be careful. The negative sign's not squared. And now I have 11 over 36. And this time my denominator stays the same. So it becomes, it's -6 over 36, which is -1/6. All that to give me -1/6. You got to know SOHCAHTOA. Sine of alpha plus beta. Sine of alpha plus beta. Sine is social. Sine alpha cosine beta. That's a good thing. Sine beta cosine alpha. And now you got to go to alpha and get sine. Alpha to get sine, root 11 over 6. And you got to go to beta to get cosine. 2 over 3. And then you got to go to beta to get sine, which is root 5 over 3. And then you got to go to alpha to get cosine, which is -5/6. I think I said one of those wrong. Yes, no? Cosine of alpha minus beta. I didn't finish that one, but I'm not going to. We're running out of time. Oh, we're running out of way pad time. Well, cuss. I'll take the quiz Wednesday. Cosine squared alpha minus. Nope. Cosine alpha, cosine beta. Clicky. That's a bad thing. Sine alpha, sine beta. You just got to know those guys. You got to know them. You got to know them. Say again. Do what? Cosine alpha, cosine beta minus. That's plus. It's a plus sign. Plus sign. Clicky's bad thing. So go to alpha, get cosine. Go to beta, get sine. Go to alpha, get cosine or sine, and go to beta, get sine. Whatever. Finish that worksheet. Finish that worksheet. Your quiz on Wednesday. Solving trig equations. Solving trig identities. 310. 310, 312. 310, 312. Yes.